Hello and welcome to a quick demo of Drogue IoT and its ThinkStack integration. This is me, I'm Jens Reimann. I'm a principal software engineer working for Red Hat on Cloud Native and IoT and on the Drogue IoT project. I'm also involved in the Eclipse IoT working group and I'm a Rust fanboy. Of course, I'm on Twitter and GitHub as well. So what is Drogue IoT? First of all, Drogue IoT is an open source project. It's about IoT with Rust in its core, and it consists of two main parts. One part is Drogue Device, and Drogue Device is an actor-based framework for writing microcontroller firmware. The twist is it is Rust-based. Drogue Cloud is IoT as a service. It's based on cloud-native technologies, and it provides IoT-friendly APIs for Knative and Kafka. And it also has some IoT-specific services available. So the question is, why Rust? And the answer is pretty simple. Rust provides performance which is comparable to C and C++. It does not need a garbage collector, and it interfaces easily with C. Now, that alone is great, but why Rust? Companies have analyzed the cause for their security-related issues in their software, and so has Microsoft, and they have published a blog post with their findings. 70% of their security issues come from bugs that Rust would have most likely eliminated by refusing to compile your application. And not only are companies aware of that fact, but they are also failed, like Microsoft, to bring that number down using C and C++. So if you want to have native compilation, great performance, no garbage collector, and a working product, you should consider taking a look at Rust, even on the embedded side. I recommend to read that blog post. You will find the link at the end of the talk. So let's take a look at a common example that you can implement with Drogue IoT. So for example, we have a Me temperature sensor that uses Bluetooth to send off its sensor data. We have a Raspberry Pi that receives the Bluetooth messages. We have a Python script that takes these messages and forwards them using HTTP to a Drogue Cloud instance. Drogue Cloud authenticates and authorizes the device. And it does the transport protocol normalization, so it converts HTTP or MQTT or whatever you have into cloud events. We have message persistence, which is done by Kafka, for example, and we can also have payload conversion. The data ends up in a time series database, like InfluxDB, for example, and we can use Grafana to draw nice graphs of that data. But for this demo, we want to turn on an LED using LoRa. This is what the solution will look like. Our LoRa dev kit should communicate with the cloud-side application, and in the middle we have the ThinkStack and Drogue IoT. Let's take a look at the different components. So we use an STM32 dev kit for that. It has a Cortex M1 core and an embedded transceiver that can do LoRa. You can see here a snippet of the code that implements the device firmware. As you can see, it is written in Rust and it looks a little bit like C or C++. We have the request that gets sent to the LoRa actor, and that takes care of sending and receiving with the LoRa network. As that may take a while, we're using the async await construct from Rust that will take care of handling any delay that may come in, and that will schedule the tasks appropriately. The cool thing here is it strings, references, async code, and interrupts, and it's all safe thanks to Rust. The next piece is the Quarkus application. That is the application that runs on the cloud side. Now you might ask, why Java? Why Quarkus? Didn't he just talk about Rust? Yes, but the truth is that a lot of existing systems use Java for good reason, and Quarkus can make Java applications fit for the cloud. So why not build an example based on that technology, just to show that it can work together? Now the important part of that application is the processor class that takes care of the incoming events, doing the reconciliation, and calculating the outgoing events that should get sent back to the device. The events come in from the MQTT integration endpoint of Drogue Cloud, and they also go back to the same channel. Drogue Cloud will then take care of delivering that to the ThinkStack, and that will take care to deliver that to the device using LoRa. And here we now can see the main pieces of our setup, mainly the device and the application, which is what we actually want to focus on. And in the middle, the communication platforms that we need in order to connect the device with our application. Now, you might wonder why not directly connect to the ThinkStack? Why push data through Drogue Cloud in addition? If you recall the example from before, we had a direct HTTP connection to Drogue Cloud. you can also imagine connecting with other communication services as well. Using Drogue Cloud APIs, your application doesn't need to adapt different APIs. You can mix and match as you need. And actually, these aren't Drogue Cloud specific APIs, but we are using the cloud event specification to exchange data. But let's go back to our example. As you can see, both systems require a device registry. So wouldn't it make sense to somehow synchronize them? Like you create a new device in Drogue Cloud and it gets synced to the ThingStack automatically. The ThingStack integration of Drogue Cloud can just do that. And here's how this works. So let's go ahead and create an application and a device in Drogue Cloud first. So we do this using the drg command line tool. We create an application first. That's it. And then we create a device like that. And we name it dev-kit. So this created the two resources, application and a device. And that doesn't contain any information so far. But we can also take a look at what it created. So we can do get application. And there we go. You get the metadata, but otherwise it's pretty empty. So next we can enable that to sync with the ThingStack. For that we need an API key for the ThingStack API that you can create using the console. And we need to add this to the spec section of our application here. So since I don't want to share my API key with you, I prepared that upfront using a different application than I just created. So we will ignore the application that we just created and we'll use the prepared one further on. I can still show you how that looks like. So you can paste that in here and you will see this is the metadata and the spec section, which of course does not include the API key. But you can see is reconciled with the ThingStack, so we can check that in a minute. We can also check the devices that we already have for this application in Drogue Cloud. So we can say get devices for the application called TTN. We see there's one TTN gateway device, which is the device that will communicate with the ThingStack. So that will receive telemetry information from the ThingStack. So now we can take a look at the ThingStack, how that looks like. We go to applications and we can see there we have one application. We can see the name of the Drogue application there and it has a different application ID in the Thing network. You can configure that so that if you run into any conflicts, you can always have an alternative name there. So taking a look here, we have the application created and we can also look into integrations and into the webhook, and there we see the Drogue IoT webhook, which is the way that the Drogue IoT cloud receives events from the Thing network. If we take a look at the devices, so far there are none, so that's the next step, what we have to do. So the next step is to create a device. That includes all kinds of information, so we'll just copy and paste that here. And you can take a look, it contains the IDs, frequency, other stuff. We just create that in Drogue Cloud. And of course, we can also get the information back. And there you see it's been reconciled. So if we switch back to the Thing console and do reload, you will see that the dev-kit device now appeared and that this is available now. So far there is no data, but if I press the reset button now on the device I have on my desk, we should see that it joins. And we can also do some data exchange by pressing the user button on the device. And there you go. So that's been the configuration of the device done in Drogue Cloud and synchronized over to the ThingStack. We can also take a look at the Drogue IoT console. So if you go there, this is the public running sandbox. We have a page called Spy where we can sniff on our own data that's coming in from devices, a little bit like the live data on the ThingStack console. So we just start that. And then again, I will go ahead and press the user button. So that will trigger data exchange. And there we go. We have the device phoning home, sending the data, and there we see the payload, which is the JSON coming from the thing stack. So here we can see the Quarkus Frontend. So that shows the latest message received from the kit. It shows that the LED is off, the number of pings or the number of clicks for the user button. We have a response. This is the scheduled response when we want to send back to the device. And then we have the latest command. So what we can do now is we can set the LED to on, and that just marks it as to send down to the device when the device calls home. So I can press the user button now on the device, and that will make it phone home. And then the cloud-side Quarkus application will check if a downlink message needs to be sent back to the device, which will then turn on or off the LED. When the device phones home the next time, the state might match and no downlink message is necessary. And if you've never seen how an LED turns on, here's your chance. Absolutely awesome. I hope this allowed you to get a bit of an understanding of what Drogue IoT and its ThingStack integration can do. Of course, there's a lot more to explore, and I encourage you to take a look at our blog or try out Drogue Cloud with our sandbox installation. You can also replicate the demo yourself using the workshop that we have created as part of our documentation. That will walk you through the different steps, including Drogue device and Drogue Cloud parts. And of course, here's the link to the blog post I promised earlier. As mentioned before, Drogue IoT is an open source project, and you're welcome to get in contact with us, find out what we have planned for the future, or even contribute yourself by bringing your ideas and thoughts. Code, of course, is always welcome. And thanks for watching.